Hey there, folks. It's Tech Tuesday. I'm Rick Husey here with Carlos Bustamante. We'll be starting in just a second. Hey, thanks for joining us for Tech Tuesday. Welcome, Carlos, to the Tech Tuesday domain.
Well, thanks for having me back.
Yeah,
it's been a little bit, but I'm glad to be back.
Yeah,
appreciate it.
Yeah, Carlos and I did a little series on PNM a little while ago that you can find on our YouTube channel. Then a couple of weeks ago, I was here with Brady Volpe, and we were talking about PNM and specifically about the intermittent modem feature in Pre-equalization Analyzer. And this is a good follow-on to that. In fact, somebody asked a question on our YouTube channel. Once you see that there's an intermittent modem out there, which is a modem that's showing you that noise is impacting that modem, and you go fix it, how do you know you fixed it? Well, that's a really good question. So we'll kind of cover that. It is kind of a challenge, but we're going to show you some equipment today that can help you be a lot more confident that you actually fixed the problem so that you don't have to go home and then check a couple days later to see if everything's fixed. And that's using that pressure testing gear that we're going to talk about today. So anyway, if as you're watching the video, you can go ahead and you should see on there on your YouTube page that you can chat with us. If you've got any questions, feel free to do that during the broadcast. If you're watching this recorded later, you can still leave a comment on the video, and if you've got a question or comment for us, if you like these videos, we'd love to know that. Just let us know. If you like the video, click the thumbs up. But you can do that after the fact, and we will go ahead and answer any questions that come in later as well. So
excellent.
Anyway, I want to go ahead and kind of give a quick, I don't want to go through the whole video again, but I wanted to give a quick preview of what we discussed when Brady was here. And down below in the comments section, you should see a link to that broadcast that I did with Brady that will give you the full aspect of the intermittent modem feature in Pre-equalization Analyzer. Now, this is a feature that's in our PNM tool, our DOCSIS PNM tool, Pre-equalization Analyzer. It's not necessarily in every PNM tool, but I'm going to be showing you what's in ours. So again, what we covered last week, if you look at this image right here, you've got a picture of the map that comes up in the Pre-equalization Analyzer tool. And you'll see on some of the map pins that we've got these exclamation points, and that is pointing out that this is an intermittent modem. And I'll explain what that is in just a minute here. So that's one way that you can see these intermittent modems. Another way that you can see those is if you go to the dashboard and go to the report section and pull down the menu, you'll see intermittent modem report, and that will list all of the modems in a report, in a table, and then you can click on those as well and see those modems. And what does that mean? So this is what pulls up when you actually pull up an intermittent modem chart. What you're looking at here is two different data points that are being plotted. One is the cable modem transmit power. Then the other one, the yellow line, is the what's called MTR, which is kind of like your MER at the cable modem. It's really what it is. It's a ratio. If you know PNM and the digital taps that you have in PNM, you've got your main tap, tap 8, and that's where really you want all of your energy going through, but that's never the case. Even in a perfect world, there's going to be probably some, in a lab, there's going to be some up and down, but generally you want most of your energy going through tap 8, and then the other taps, the other 23 taps will adjust depending on what they're seeing, what kind of impairments they're seeing in the cable plant in order to make the signal what the CMTS wants to see. And as those change, as you see those pre-equalization coefficients and taps changing, that sometimes can correspond with how the cable modem power is transmit is changing. And when you see those two things correlating, like on this chart you're seeing here, the red power line goes up, and as it's doing that, this MTR line is going down. And then again, they kind of coordinate in the up and down pattern here. And what the application will do is correlate those things, and when it sees a definite correlation, which is generally, I think Brady was saying a minimum of 2 or 3 data points that it has to correlate, it will then draw a green line and really point it out for you. But I mean, you can look at this visually and see, wow, these things are really correlated. And what that's telling you is there's a very high confidence level that noise is coming into the cable plant by this modem somewhere in the home or near the home at the drop, something like that, that's impacting this modem. So that's great to know. You've got this cable modem out there, and you can look at all of these modems. You can sort on the application on the intermittent modem report. You can sort it by standard deviation, which will tell you which ones are the worst, that are really deviating a lot as far as the power goes and the difference between these two things. So that targets those. Now, what do you do from there? You could go, you know you've got a problem out there. You could go out to the home and you can look for the obvious things that you would look for, which would be a loose connector somewhere at the, where it's coming out of the green box or whatever you've got. Going up to the house, you could look for corroded connectors, and you might fix that, and that might solve the problem. But the question we got was, how do you know you fixed it? And this polls every couple of days. So here you might have to wait 2 days before you realize whether or not you've actually fixed the intermittent modem or intermittent portion of that, right. The problem, right? So that's a challenge. Now you could go to the tool and you could look at the digital taps and see if they've changed, because on the P&M tool, when you look at taps 9 and 10, those indicate a near home problem,
right,
or an in-home problem. And if you saw those before and they were elevated, and you saw them after and they're not elevated, that could be an indication that you fixed the problem. But as I showed you here on this map, you can see right here, you can have a green modem that at the time that it's being polled right here where it's showing green, it was not an issue because it's intermittent. So it could be that the digital taps are not really in a bad situation right here. So that does make it difficult to know, hey, have I fixed the problem? And then, of course, what if it's buried cable? Are you going to go, how are you going to find that? So that's where what we want to talk about today, where something like a pressure test kit could really help. And I was going to turn this over to you now, and you can maybe talk a little bit about this. And this is a particular brand that we actually offer that you can get from us. So.
Sure. So let's talk about that. So the idea is the solution is more of a pressurizer and detector combination. So it's called the DRB3 or DSG1 light kit. So the concept is, now that through the P&M platform you've identified the intermittent modem, or the modem that is generating this type of behavior, now what? Now what do we do? So you're going to see shortly a little video on the steps, but at a high level, what we're doing is this. You have an injector and detector pair. Where you would do is you would disconnect the drop at the tap, and at the tap, you would put the pressurizer that works in the mid-band as well as the LTE band, and essentially you are transmitting towards the house. So of course this is a service impacting activity. So the idea is that the field tech will be able to coordinate with the end customer, that this is going to occur, or if they know for a fact that the end customer is not at the house, they will do this type of activity and pressurize from the tap back into the house.
And that's important because it could be customer affecting for a lot more than one customer if you go the wrong direction.
Absolutely,
So
absolutely.
make sure you go toward the house. Yeah.
So what you're going to see in the video is connecting the pressurizer towards the house. So now that you have a consistent signal going back to the customer prem, that's where the detector comes in. Mm-hmm. And the idea is the field tech will actually walk towards the ground block that's beside the house and listening for an audible tone that will increase or decrease based on detected egress.
Mm-hmm. And you also can see, as you're looking at this, and you can see the little handheld unit here that you're walking around with, you can see these numbers change. And so there's a pretty good indication, both with the tone and then watching the numbers go up and then eventually down.
Absolutely.
Where you got your issue. Yeah.
And the idea is it's highly unlikely it's going to be one cause. It might be multiple causes. But if the field tech has coordinated with the end customer that this service impacting activity can occur, they're walking the line to the outside of the house, listening for the audible tone increase. Once they get and find a place that it's essentially audibly screaming, then they will make a repair. Maybe it's underground, maybe it's at a connector. Mm-hmm. And from there, do the repair, the update, replace the connector, and then move down the line. What that means is that maybe at this point, you go back to the pressurizer for where you once connected it, go a little bit closer to the house and connect it to that point until you've exhausted everything that's happened on the outside.
I guess if you make that, yeah, you could leave it connected where it was, and if you've made that repair wherever it is, you can tell at that point with the handheld unit, okay, well, I've fixed that.
Right.
And I guess you can also walk a little further and see if you...
Absolutely. So to your point, if after the repair has been done and they don't hear an audible tone to the degree it was before or at all, then we have confidence that it's been repaired. In addition, you can go back to the PNM platform, do a refresh on that particular device. At this point, we're expecting that the field tech has something to compare to as far as all the digital taps, more of a before and after look.
So you can have his mobile app out and you can look at the digital taps before and after.
That's right.
Yeah.
So once they've exhausted that everything on the ad side has been taken care of, and yet the PNM platform still shows that there are some issues or some elevated taps 9 and 10, maybe it's more inside the house, and that's where you're going to have to coordinate and make sure that you have permission to go inside.
Yeah.
But yeah, so that's what we're going to see. Our good friend Brady being able to walk through his video.
And I know that some I don't want to call it research, but basically some real world research has been done on this, where it's like, let's find an issue on the PNM platform. Let's arrange to go out to these various subscriber homes and see if we can find and correct the problem. And the correction rate on that was very high. It was like almost 100%.
Oh wow! Yeah. I can believe that.
Yeah. So so this is something that works. And again, with these modems being intermittent, that generally a lot of times will mean that maybe that modem's not being impacted all of the time. So it's not like the steady noise like what we were talking about a couple of weeks ago with Brady. If they're growing pot in their house, they've got these grow lights on, that might be having a steady level of noise. But because they're intermittent, what this kit will do is it's not intermittent anymore, because basically you're injecting all of this noise, this signal into the cable plant, that you will find the leak, basically, because it's you're going to be kind of driving that noise down the line. So right now we are going to show you this again. This is Brady is going to take you kind of through the process of hooking up this unit. You see the green unit there next to the handheld unit. He's going to hook up to the box, and then he's going to walk through, and you can kind of see how this really works in action. So we'll show you that right now.
Hi, this is Brady. We're at a house with a red modem. We're going to be using the Effigious pressure test kit in order to identify where the impairment in either the drop or the home is. I'm going to disconnect the drop from the pedestal. Then we take the Effigious pressure test unit here, and so this is the drop going to the subscriber's home. And when you put that on, make sure you wrench tighten onto there. Turn our pressure kit on to the high level. You should see a green ring around there when that's on the high level. And now we are pressurized. So we know that the line runs somewhere between here and into this house. On the antenna here, there's a donut pattern. And that gives us sort of directionality, so we can run and sort of walk the line. You see we're getting 0 to 1 microvolts per meter. I'm starting to get 2 microvolts per meter. It's telling us we're getting close. 2 microvolts, 2 microvolts, 3 microvolts, 5 microvolts, 7 microvolts. So as this number starts to go up, now we're up to 8 microvolts per meter. This is telling us we're getting closer to a leak. 6, 7, 11, 19, 23. So this shows that it is possible to find some sort of impairment in a buried drop. 53, 83, 88 microvolts. Now we're up to 160, 190, 180. Okay, so we just passed where the impairment is, because now our leakage is dropping down. So I'm going to go back. Remember, as I said, there is a donut pattern around this antenna, So it's directional to the leak in this plane. So I'm going to go back. Now we're at 220, 210, 220, 200. So it seems like the leak is strongest right in this direction. So I'm going to take my wrench, put it that way, because we know the leak is somewhere here. Could be over there, could be back here. What I'm going to do now is turn the meter this way and walk back up, and we can triangulate then on exactly where the leak is. So there's 280, 300 microvolts per meter. I back up, 270, 240, so it's starting to drop down. 280, 310, 300, so 310. So our max is right here. So this is where our wrench was when I found the leak this way. This is where our leak is. So I put this right here. Our leak is right in this area, underneath this stone. Fortunately, it's a light stone. And let's see what's going on. Gently. Oh, right there's the cable. Looks like it's a black cable. So we see what our problem is here. There is some electrical tape on that cable. So we can tell that this cable has been damaged, and it looks like it has been repaired with electrical tape rather than having a proper splice put on here. Obviously, holding the leakage meter on here, we're seeing very high levels of leak. Electrical tape is not going to be water sealed. It's not a proper fix for this coax cable. So we are going to need to have a new drop put in here on this, but this is clearly the reason for the micro reflection, the reason that this modem is likely red, and this is not a proper field repair. So this is the reason we're having issues on this particular home.
So I have to confess that in a former life I've done that before I realized that actually, you know, nicking a piece of cable could actually have this kind of impact. So I think I've probably used a little electrical tape in the past, maybe when I was doing some gardening, kind of similar to this.
Nice.
Yeah. But I think that's probably a common occurrence. You know, people, I think in general, people don't realize that, you know, you put a little cut in a cable and you think, well, it's just a little dielectric or whatever on the outside. It's not going to make a difference. And it certainly can. So
yeah, usually the end customers realize things like that, maybe adding additional splitters or splitters with bad connectors. That could lead to this as well.
Yeah. So as you can see here in this example also, this would be very hard to find, obviously, without this equipment, because you've got something that's buried, and you could go out there looking for connectors and whatnot, and maybe would have a hard time finding it. Now, the TDR in the tool does give you kind of a distance of the, I guess it's the echo cavity. So
frame of reference, yeah.
It can help you search for things, but obviously this can really help you pinpoint it. So we think we recommend this highly if you're going to be trying to resolve these kinds of issues at the home. And again, as Brady mentioned, we were talking 80 to 90% of the noise that's leaking into your upstream is coming from the drop or in the home somewhere. So this can make a big difference for you.
Yeah, definitely the P&M platform is complemented with this type of Effigus detector pressurizer pair, and definitely recommend it.
Yeah. And I think it's not that expensive. It's what is it, like $1,100 or so for the pair.
We'll have to ask our good friend Will Baker.
Well, that's a good point. Yeah. So first off, yeah, if this is something you're interested in, you can give Will Baker a call, and you've got his number right there, the phone number, and his email. Just contact him, reach out to him, and he can help you with that. If this video, again, was helpful for you, if you like this video, go ahead and click the thumbs up. You can always subscribe if you're not already. Just go ahead right under the video, not right here on the screen because it won't do anything. But if you go under the video, there should be a subscribe button that you can click, and then also go ahead and click the little bell. And when you do that, you'll be notified anytime that we're live or anytime that we post a new video, whether it's recorded or live, you'll be notified. So, all right, anything else to say?
When's the next video?
Well, it's not going to be in the next 2 weeks because Tech Tuesday is taking a holiday break, Tech Tuesday, because I'm going to be taking a holiday break, and So we'll be back in about 2 weeks, I guess it is, after the first of the year. We will be back with Tech Tuesday, and we'll have a new topic then.
Excellent.
All right. So
All right, see you then.
yeah, thanks for joining us, and we will see you then. Bye-bye.
Thank you very much.